So, okay, what's my recommended resolution for this screen over here?
Sorry.
1024 by 768, I think you said.
Yeah, 768, sorry.
That'll
Okay.
make it longer.
Yeah. Alright, that is a bit of an issue. But we will run with it.
We just moved the projector, but it's attached to the ceiling.
Yeah, that is a bit of an issue.
Move the window.
Not if it's full screen. Which, Alright, that'll do. Okay. So. Alright, now that we have that all figured out, so I'm with Decorators. How many people have actually used Decorators before? Alright, pretty good number. How many people have written Decorators before? Same people. So at the end, hopefully you'll know how to write Decorators, and also if you've written crappy Decorators before, you'll know how to write good ones. So I'm gonna tell a few white lies along the way, just omit some details because it'll make life easier. You can find those out pretty easily if you look around them. All right, so a decorator is a function that lets you modify other functions. And you can use them on your own functions, but more interestingly, you can use them on functions from imported modules. So if someone else has defined a function and you want to change its output or its input, then you can use a decorator to modify it without having access to their source code or anything like that. So the long way of using a decorator, say we've got this decorator that does caching. Basically, whenever you run a function through this caching function, it'll automatically save the values and store them for you, stuff like that. So what we're doing is we're giving a function, and we're replacing the reference to the original function with this cached version. So now, transparently, anytime someone tries to use that function, it'll go through this cached version first. So after Python 2.4, they added this special syntactic sugar for giving it an official name, calling it decorators, where you just write @cache before the name of the function that you want to modify. So here, let's say your coworker wrote this caching thing for you, and all you do is you just write @cache and you're done. And you can reuse that, any of your functions, whatever. And it's really easy. You can add a lot of functionality this way. If you're an object-oriented kind of person, some really useful decorators exist, stuff like class methods, static method, and properties. And properties is really nice because it gives you transparent getters and setters. So if someone just does, foo.x, it'll automatically go through your getters and setters, which is really nice. So let's say we have a function like this hello function down at the bottom that doesn't take any arguments. So if we want to define something to modify that, first we have to have this kind of nested structure. So here verbose is going to be our decorator. As you can see, it just says, I'm the decorator. It receives a function as an argument. Then we have the wrapper. It's going to call the original function, and it's going to use the same arguments. So because hello takes no arguments, the wrapper takes no arguments. So we're going to save the result of the original function, print some stuff, and then return that result. So here down at the bottom, we're replacing hello with this verbose version, and if we run this, what we get is that before calling decorator, we've got this hello function. Then the decorator happens, the wrapper gets called, it tells us that we called the function, and then one kind of strange thing happens at the bottom. After we've called the decorator, when I ask for the name of the hello function, it tells me that the name is wrapper. So that means that the original hello function has been replaced with this wrapper here that we defined. And if you were debugging, that would be kind of annoying, but for the sake of our simple example, it works well enough. So if your function actually has arguments, it gets a little bit more complicated because your wrapper has to receive arguments as well. So here we've got this decorator called elementwise. So basically what we want this to do is, let's say we've got this function down at the bottom, compute. It takes a single number and it does some calculations on that number. But if you want to call it on a list of numbers, you have to use map or whatever, and you have to use it all over your code. So this element-wise thing, it will map the function across the list of numbers for you automatically. So whenever you call it, if you call it with a single number, it'll work. If you call it with a list, it'll work, whatever. So, wrapper takes one argument, function takes one argument, we pass it on, it all works. So if we run this with a single number, which is off the screen because of low resolution, the single number gets computed. If we call it with a list, it does the computations and it returns a list. And if we call it with a tuple, it works the same, it gives us back a tuple. So that's kind of nice because it keeps the same thing you gave it. So neither of these decorators is really all that useful because it only works on functions that basically you've written. Like if it takes no arguments, you know that, or if it takes one argument, you know that. But if you want it to be more general, you want to use the decorator over and over again, or for a wide variety of functions, then it needs to support a wide variety of arguments. So if you've never seen this before, you can see the wrapper has this args and kwargs thing. Basically, this is just how you let a function take any arguments you pass it. And then, whatever the wrapper gets, it just passes on to the original function, or whatever. So here we've got this benchmarking decorator. Basically, it's going to tell us how long a function took when we put the @benchmark line before it. So at the bottom, we've got this waste time function. We give it a number of seconds. It waits that long, and it's got some other keyword arguments that it's going to print out. So if we run this, it's going to take 9 seconds because I called it 3 times. And it's going to tell us how long it took each time, as well as it's going to print out its arguments so that we can see that they were passed along correctly by the decorator. Or it's not going to work. That's the alternative option. Well, if it had worked, it would have said, it took 3 point whatever seconds, and actually, technical difficulties. I was being too clever for my own good. There we go. All right, there we go. Here is where it actually runs that code. So you can see we're trying to waste time, and we're claiming this is the best presentation ever. And it tells us it took this much time. It prints out, this is the best presentation I've seen all day. Since you probably haven't seen many presentations today, that's more or less a guarantee. So that happens automatically for us, and it's very nice. So the next level of complexity up from here is a decorator factory. So let's say that this decorator here does the same thing every time, but let's say we wanted to modify what the decorator does. In that case, we need to use a factory, which is going to return a new decorator every time you use it. So the basic structure is kind of similar to this simple code where you call the example function with the return value of the test function. So like here we've got this test factory function. If it returns a function, we can call that with some arguments. So when you're using a decorator factory, you call the decorator, give it some arguments, and then you give it the function. So this is the long form of doing that, but nobody wants to use that. So here I've got this decorator factory for deprecation warnings. So what it does is it asks you for a replacement function, then it creates a new decorator, returns that, and that's applied to your function. So whenever we put this on a function, it's going to say, oh, don't call this anymore, you should use this other one instead. And then it will call the new replacement automatically with the arguments you gave it. So I know that's a lot of code, but it's it'll be fairly easy, I think, to watch what happens. So here we have this really crappy function defined some couple. It just adds 2 numbers together. But obviously, that can be replaced with a much better function up here, this sum many function. It just takes a list of arguments or list of numbers, and it adds them all up. So at the top, we're going to call the factory function without any arguments, and we're going to save its return value. If we give it a replacement, I can also save that value, and we'll see that it actually returned a decorator there. And then at the bottom, we're going to run the sum couple and see the deprecation warnings. So we run that. It tells us at the top we're calling it no arguments, and then the factory tells us you called me with none. Then if we call it with the replacement function, it says, oh, you've called the deprecated factory with some many. Then at the bottom, when I had the at line, it tells us that the factory actually returned a decorator, and then that decorator gets applied. So now that at the very bottom, when I try to call a sum couple, it tells us it's decorated, you should use that smaller one instead. And then it automatically calls the other one. So if you're writing a library, this is really quite nice because nobody has to modify their code. It's just going to automatically go to this new version instead. So that gives them some time to make the adjustment they need. So remember at the very start, when we decorated the hello function, it replaced the name of the function. It told us the name of the hello function was now wrapper because that was the return value of the decorator. So that's really annoying, especially if you have an error in your code when your backtrace is just going to say, oh, you had an error in the wrapper function, and you're not going to know which wrapper function it is because you've got decorators all over the place or whatever because they're so great. So there's two solutions to that. There's the built-in functools.wraps decorator, and there's also a decorator module, which is a bit older but also offers some more functionality. So if we're using functools.wraps, you would use the wrap decorator on the internal function, the outside wrapper, and then that would take care of the whole naming thing. It would update the doc strings and some other things like that. So if you're actually going to use decorators, you'll want to do something like this. So this kind of retains the nested structure of the earlier examples, which can be kind of confusing to follow. So the decorator module replaces that, and it lets you remove at least one level of nesting. So if you're using the decorator from the decorator module, instead you set up your decorator to take a function, then star args, then star KW args. So you've eliminated the outer function. All we define now is the wrapper instead, and it works the same, but it's a bit easier to read. And of course, it doesn't mangle the attributes of the original function you're decorating. So, it's kind of an aesthetic thing, really, between which of these you prefer. They work more or less the same. So, one trouble with decorators is that they can be kind of complicated, and especially for debugging purposes, because you can never get back the original function, at least if you use the at syntax. So Chris McDonough, the author of Pyramid, he doesn't think decorators should be used excessively. If something is really important, you should just write it inside your function. That's, it's just the simplest thing, and when someone else is reading your code, they don't have to go and look up the definition of the decorator you're using or anything like that. So that's kind of really going to be the deciding factor, whether you put something in a decorator or not. Like if you had a logging decorator, you might not want to actually use it that much because you might want a function to always log something and not sometimes log it. But if it's like you're debugging and you want to turn on logging temporarily or something like that, this can be a good idea. But otherwise, some people might say it's clearer and easier to figure out what the function is going to do if you build the functionality in. But on the flip side, frameworks are a really useful place for decorators because when you use this at syntax, it passes along your original function to the decorator. So frameworks, stuff for the web like Flask and Django, or if you're making a command line application, they want to run your code. Like here at the bottom of Flask, the main function calls a Flask function. You don't have your own main function. You kind of delegate everything over to Flask. So the reason that's possible is because we have this app.root decorator, where when you call the run function from Flask, it's going to have all of the functions you've defined and it will know when to use them based on what you pass into this decorator factory here. So, if you're writing something that is meant to kind of make use of other people's code like this, it can be really useful. Or here's another example for command line applications. There's arg, which has this command decorator where any function you apply it to is automatically exposed to anyone who uses your program. So if I were to call this program with the hello argument, because that's the name of the function, it would print out that string and off we go. So I don't particularly like this actually because it's not very flexible, but that's just me. So I mentioned earlier that you can use decorators in other people's code. So let's say someone else defined this bar function and they return a string for you, but you don't actually care about a string. You want to put it out as HTML or something. So you could make a decorator that changes the string into totally a state whatever HTML version, and then you can save it with a new name. And then internal to your own module, you can use this modified version, and it will work just the same. It'll just change the output or what have you. Or you can replace the original name, but you kind of have to be careful with that. So the one catch is that you might think, oh, I can redefine anything. It's great, but I tried this today. It doesn't work for the standard library. I really dislike string.join, but you can't replace it. So that was kind of sad. So my last note is that decorators work via closures, which is a scary word and it sounds very academic and pointless, but it's actually not, because decorators and a lot of other cool Python stuff is totally built on closures. And I'm not going to go into it too much. This is a fairly short presentation, but I learned about this from Matt Harrison's ebook, or you can give it to me later. So I thought I would compile a list of all the decorators that I looked at while I was putting this presentation together to just kind of argue for them actually being useful. So I showed you earlier the deprecation warning function, and there's another one that's too cool for its own good because it's not actually that useful, that will turn recursive functions automatically into loops. So, maybe you probably don't want to use it in production code, but if you have something that's, calling itself 2,000 or more times, this will actually give you a bit of extra speed. But if it's not calling itself that many times, it will actually slow things down. And then I mentioned the caching thing earlier. In Python 3.2 plus, this is built in. If you're using an earlier version, you'll have to define it yourself, but it can be pretty useful. And afterwards, I've got all these other links in the files for my presentation, so you can see those later. And if you're writing decorators after this, because you're so inspired, I have some other useful links. The one I didn't mention in the presentation yet is something called Venusian, which lets you delay the application of your decorators. So normally, like this command thing is going to be applied when the module is imported. So you never actually have access to the original function no matter what. Whereas with Venusian, you can delay that. So if you have some kind of testing that you want to do, you can do it on the original function, and you actually have access to it. And then on demand, you can apply all the decorators that you want. And then I have a bunch of other notes that I took, and you can see those afterwards. So that's it. Any questions? Yes, right.
So the decorator pattern, which is separate from
Yes.
this, is usually done at the class. It's done on classes, basically.
Yeah.
You write another class that wraps another class that usually has one method that you're wrapping. So if you want to use this in that manner with inheritance, how does that interact? Like how do you decorate something that already exists?
Right. So if you can actually redefine methods just the same. So I was trying this earlier. If you have a class, let's say you've got a word class, for example, it's got a function 2 Unicode. You could say word.2 Unicode equals decorator blah. So you can do that after the class has been defined. But you can also apply it to the methods of the class within the definition of the class. And there's also, I didn't go into them here, but there's something called class decorators, which apply to the whole function class definition rather. So that may be closer to what you want. The other thing I didn't mention is that you can apply decorators with classes. So that may also be more useful for that use case. Like you might, so you have this, like the init function is it creates the constructor, then the call function is the wrapper, and so on and so forth. So those are a few other things I didn't go into. Yes?
A little bit unrelated. How did you set up Emacs to do your slideshow?
Well, that's on my GitHub, which will be linked to afterwards. And I'm sure most people here probably don't want to talk about this, but I will be happy to brag about it. Anyone else? All right, well, thank you very much. Oh, yeah?
I have one question.
All right, sure.
You mentioned earlier on, there's some cases where they're greater than great and some where they're not so great.
Mhm.
Do you have in mind either one use of decorators to be considered particularly horrible or one considered to be particularly brilliant? You can pick and choose or both of them.
Yeah. Well, I mean, I don't think they're ever really horrible. It's more a question of like whether it's appropriate. Like, let's say you are, you're writing your program and you think, oh, this is great. I'm going to make like 7 decorators, and then my original function can be like 1 line long, and I'm just going to apply all 7 decorators all at once. Probably not a good idea. The way things interact when you've got multiple decorators to one function, if they're not well written, it will just break. But I think it can work. But that would be one definite case where you have a lot of functionality that you're trying to generalize. It's probably better to put it in the function itself. As for particular brilliance, I think this element-wise one that I showed earlier is really great because it lets you say, call me with a number, call me with a sequence, whatever, it's going to work, no matter how many things you give it. So I think that's kind of nice for your API that, it can handle that and the user doesn't have to do it anymore.
I know NumPy has a feature where its methods, like it finds a lot of functions that seem very similar to static library, like square root and all that. They have functions that will work on their array objects, so
Right.
whatever the dimension or size, it will work on every element. Do you know if they use something like decorators there? Probably not, because it's mostly for C, I think.
Yeah, they probably wouldn't.
But you could to get that.
Yes, for that same functionality in your own code, you could definitely do that. And probably if you were dealing with matrices, you might do 2 decorators or something. But yeah, and then I have a bunch of other links here, some of which are pretty cool, but also not good to fit on one slide. So, well, thank you all. You've been a great audience for not interrupting me and stuff.